Hello. This video present to you X-IoT, a model-driven approach to support IoT application portability across IoT platforms. This work is made by several members of the ProsLab research group at the University of Camerino in Italy. Nowadays, one of the most used components to build IoT applications are cloud platforms. They offer a high computational capacity and make it possible to develop applications by connecting devices to them. They allow manipulating the data received from the devices to produce more significant ones, and graphically displaying the application via the dashboard. However, the process for building applications on top of them is very specific and strictly based on the platform you are working on. Among the major causes of this fragmentation are the heterogeneity of the devices and the data they display, the various frameworks on which the platforms rely, and therefore, the functions each can provide. Even the final application is affected by this fragmentation and, at present, it can be strictly used only in the context in which it was created. Indeed, no common way to describe and support IoT application development with IoT platforms has emerged. We mainly focus on the problem of portability, which does not allow an application created within a platform to be exported and integrated into another platform. This can in fact be useful when a platform can no longer provide its services, or when the IoT application wants to be expanded but the platform does not provide the appropriate tools for the new features. This leads to the users being in a vendor lock-in phase as they cannot move to another platform. Even thinking of developing the application from scratch on a new platform has disadvantages such as data loss and having to rebuild the entire solution at high costs and in a short time. Finally, in order to do this, experts are needed with high knowledge of the developed IoT solution, as well as of the platforms. For those reasons, we developed X-IoT, a model-driven approach that follows the typical path of a model-driven technological solution. Indeed, X-IoT allows the designing of high-level IoT applications, enabling their portability across different IoT platforms. To do this, we developed an end-to-end approach composed of different phases, actors and steps to guarantee the separation of concerns principle. In this approach, we first design platform-independent models representing the general IoT application without any technical information. Then, the proper platform-specific models and the final code to deploy the application are derived through some refinements and translation. X-IoT shifts the focus from the one-size-fits-all formula to provide a high-level representation of concepts that can be instantiated inside an IoT application, independently from the final IoT platform to use. In this way, we enable cross-platform IoT application development, as the abstract concepts instantiated can be deployed over several IoT platforms. The X-IoT approach is not specific to any IoT-related domain, as it provides a level of abstraction that can be applied to any IoT domain. Indeed, X-IoT provides high-level concepts represented inside models that allow to describe an IoT application, without any technological and platform-dependent information. The abstract application is derived as a platform-independent model, and it is focused on representing abstract concepts. Then, based on the platform chosen, X-IoT provides some instruments to derive specific platform models based on the platform's specific requirements. Finally, the code can be deployed inside the target IoT platform. To test the X-IoT approach, we developed a ready-to-use tool in which is possible to model abstract IoT applications and derive platform-specific solutions. The tool is provided inside the OMALab repository web page. In the following, we will show you the applicability of our approach over a guided example, representing an example IoT scenario. Open the X-IoT tool and go to Model New, to create a new project. Select one model type, and choose the name for the model. IoT scenario model type allows you to create custom IoT systems. You can model your scenario with systems and devices elements. They can either have attributes, services, locations, and widgets. Each element can be related to others, using specific connectors. Double-click on the elements to view their information. At this stage, items contain only basic fields to describe them. Add information on those fields, to enrich the model. Now select the IoT logic model type, and create a new model. This kind of model allows you to define the application logic. There are many kinds of nodes, each one has a specific function. Nodes are linked using connectors to represent the logic flow. As for IoT scenario, at this stage nodes contain only basic information. Set the name and the description for each node. You can also set a label for each connector to describe its output. Once done, go to the conversion menu and select the target platform. Choose the destination path and the name of the converted model. The tool will automatically create a new platform-specific model. Repeat the same process for every model you want to convert. Elements now have additional specifications, based on the selected platform. You can select the PSM type of objects, and set detailed information. Go on conversion, generate files to produce the final code. Choose the path where save files, and the name for your application. Repeat the same process for every model you want to convert. The tool will generate all needed files, ready to be uploaded. Go to the target platform, in this case Things board. Import files on proper sections, and make refinements where needed. Elements will be automatically created inside the target platform. Once files are imported, you can see the results of the application.